Okay, for this problem we're just finding relative frequencies for the frequencies listed here, and we had a total of 5,000 participating households. So that means that we're going to take each frequency and divide it by 5,000 in order to get our relative frequency. And here, since it just says relative frequency and not percent frequency, that means we're going to be using the decimal forms, so we don't need to convert them to percent. For the poor rating, the relative frequency is 0.075, and we'll just go down the line here and divide each one of our frequencies by 5,000 to get our relative frequencies. Now when we get done, in order to check this, we can add all of the relative frequencies together, and they should add up to 1 or be very close to 1. There may be enough rounding error that they could be just a little bit off of 1, maybe by a tenth or a hundredth, but not more than that. Now, part B of this question is, what type of data is the rating variable? Is it qualitative or quantitative, and what is its level of measurement or scale of measurement? So the rating variable, qualitative, but the level of measurement would be ordinal because we can put the ratings in some type of order that makes sense. Okay, for the next problem, we're comparing a couple of graphs. We have ticket amounts for female drivers and for male drivers. And first we're finding the class widths for each of the two frequency distributions. And remember, to find class widths, you go from the bottom of one class to the bottom of the next class. So for both of these, for example, from 25 to 55 is a total of 30. So that would be our class width. Then for the percentage of male drivers that paid less than $85, we're looking at those first two classes and adding up the percentages there. And in these we just have to kind of estimate from the graph. The first one looks like about 5% and the second one looks like about 15%, so we could estimate that would be a total of 20%. And for the female drivers that paid less than $85, again we're looking at those first two classes, estimating where they are as percentages, and we're adding the percentages for those first two classes together. So for the first one we could say we have about 43%. For the second one it looks like about 36%. So if we add those we get 79% approximately. Now the last question asks if there's anything misleading about the way the two graphs are presented, and if so, what should be changed in order to correct this. If you look at the two scales, the one for the female drivers only goes up to 50%, but for male drivers goes up to 70%. So since they don't have the same vertical scales, that would be misleading. It makes it look like the frequencies for the male drivers are about the same as for the female drivers, which is not the case. So in order to correct this, we could use a scale for the female drivers that would be comparable to the scale for the male drivers. In other words, we could make the scale for the female drivers go up to 70% so that we could compare the two graphs side by side. Now for this problem we have average ticket prices for a Denver Broncos football game, supposedly last year. And then we're looking at the mean cost for a family of 4 to attend a game, the mean and the standard deviation for that. So first of all, we're just going to find the z-score for a family that spent $364. So we're taking our 364, which is our x, minus our mean, and then divide by our standard deviation. So our mean was 503.66. Our standard deviation was $68. So we take the 364 minus the 503.66. Notice in this one, since our value of 364 is smaller than the mean, we're going to get a negative number for our z-score. So here we end up with negative 2.05 for a z-score. And whether we consider this an outlier or not depends on what type of rule you're using. if we consider something to be an outlier. If it's more than 2 standard deviations away, then it would be an outlier. If we want to go to 3 standard deviations away, it wouldn't be. And for part B, again, we're finding z-score for a different family that spent $725. So again, we're using our mean and standard deviation, putting in the 725 for X. And here we get a z-score of 3.26. Notice this is positive because the value was larger than the mean. And this would definitely be an outlier, no matter how we looked at it, because it's more than 3 standard deviations away from the mean. Okay, for this problem, we're just trying to find the scale of measurement for each of the variables shown in this table. And this is, in some of your homework problems, if it talks about the level of measurement and the scale of measurement are the same thing. So when we look at the different variables, we have the number of items, which would be a ratio, level of measurement. The sales would also be a ratio. The gender would be nominal. Marital status would be nominal. The age category would be ordinal, because we could put that in order from youngest to oldest. And the account start date would be the interval scale. Now part B of this question has a frequency distribution, and we're using the frequency distribution to find the mean if this is all the data that we have. So to do this, we need to find the class midpoints for each class. And remember, to do that, you add, or basically you average the upper and the lower class limits for each class. So for that first class, we would average the 20 and the 34, since those were the 2 class limits. And the average of those 2 would be 27. So that's our class midpoint. Class midpoint for the second class would be the average of the 35 and the 49, which would be 42. For the third class, we would end up with 57. And for the last class, the average of 65 and 79 is 72. So if we write those class midpoints, just making a third column in our table, then we're going to make another column where we take the midpoints times the frequencies for each class. So for the first class, we're going to have 29 times 27. And we're just going to go down the row, and for each row in the table, we'll multiply the frequency times the class midpoint. Now if we add those results together, we end up with 4,260. Now we're going to divide that result by the total of the frequencies. Which is 100. So if we divide 4,260 by 100, we get 42.6. Now another question for the class width. Remember, to get the class width, you look at 2 consecutive lower limits or 2 consecutive upper limits. So for example, we could look at the first 2 classes. We have 20 as a lower limit in one and 35. as the lower limit of the next one, the difference between those two is 15. So our class width is 15. Okay, now we have a probability question. In this one, we had a survey. There were 3,042 responses of yes and 2,184 responses of no. So first we're just finding what percentage of responses were yes. Now when you do a problem like that, you have to make sure that you're dividing by the total. So the total responses that we had would be 3,042 plus 2,184. So we're going to divide our 3,042 by the total, which was 5,226, to get our percentage of yes responses. And that's approximately 0.582, or if we put it in percentage form, that's 58.2%. Now, if we look at these poll results and want to find the probability of randomly selecting someone who wants to live to be 100, then we'd be estimating that from our poll results, and the probability there would be 58.2%. So it's the same answer as in Part A. Okay, here's another question. We're only going to do some of the parts of this question, since some of these we're either not covering in this class, or I wouldn't have you do these types of questions on a test. So we are going to find the mean weight of the stakes in this problem. So we just add up all those numbers and divide by however many there are, which there are 20. So if we add all those numbers together, we get 386. We're going to divide that by 20. And that gives us 19.3. Now for the median weight, we'd have to sort our list first. So put it in order from smallest to greatest first. Then since there are 20 values here, we'll have to take an average of the 2 values in the middle of the list. So here's our list sorted. Now we're looking for the 2 values in the middle of the list. So actually here we'll end up taking the value in the 10th position and the value in the 11th position and averaging those 2. And that would turn out to be the 19 and the 20. So the average of those 2 is going to be 19.5. Okay, now we're skipping the next 2 parts since I wouldn't ask you to find standard deviation or variance on the test. So let's go on to Part E. So based on just what we've seen from the mean weight and the median weight, the question is, do the stakes appear to weigh enough? And the problem said the weights are supposed to be 21 ounces. And since both the mean and the median are in the range of 19.3 to 19.5, we'd have to say no, the stakes don't weigh enough. Now for Part F, the mode of the weights, the value 20 appears 8 times, and that's the most that any value appears. So the mode for this would be 20. And finally, the level of measurement of the stake weights would be the ratio level. Now here's another question with a survey, and we have ratings and frequencies. This is a probability question. So based on these survey results, what's the probability that a randomly selected viewer will rate the new show as average or better? So that would be average, above average, or excellent. So the total of our frequencies is 80. So we would take the average, above average, and excellent frequencies and add them and then divide by 80 to get our probability. That gives us 61 divided by 80, which is 0.7625. Okay, in this one we have a table with blood types of blood donors, and first we're finding the probability that a randomly selected donor will be both Rh negative and type B. So we're finding where those two intersect, and there are only 15 of the donors that met both of those conditions. So we're taking our 15, dividing by the total, which was 700, and that gives us 0.0214. The next is an OR instead of an AND, so we want the probability that they will be Rh negative or type AB. So we're going to look at every cell in the table that meets one or the other or both of those conditions. So we have all those circled. We're just going to add up all 5 of those. And just when you're doing these, be careful not to count anything twice. So if we add those up and divide by 700, we get 0.19. Now the next one's a conditional probability. Donor is Rh negative given that they're type AB. So we just look at the AB row. There are 32 total donors that were AB, and then 4 of those were Rh negative. So we're just taking 4 divided by 32 to get our probability. So that's 0.125.